Chapter 4, Section 6 deals with graphs of reflections of points. Once again, we're going to be continuing our understanding of the coordinate plane. The content objective says students will graph reflections of points on the coordinate plane, and the pacing guide suggests this is probably going to be a 2-day lesson. The content, I don't think is going to be that complicated though. Of course, we want to highlight our title. When you look in a pond and see yourself, it is all due to light waves and laws of science. A reflection is a bouncing of light rays off a surface, and when those waves reflect off a smooth surface, the reflection is a mirror image of the original figure. And you can see in the photograph they have a reflection of the mountain, which is the mirror image of the real mountain up above, although granted it's a kind of fuzzy mirror. In the photograph, what do you notice about the distance between point A and the horizontal line and the distance between point B and the horizontal line? Well, you can see point A is going to be the same distance above the horizontal line as point B is going to be below the horizontal line. That's reflections in a shoebox right there. I mean, everything just fits perfectly. All you're doing is if you're up here at A and it wants to reflect A, you go boop, the same distance down for B. And that is pretty much the whole point of this entire lesson. It really is going to be this simple. So our introductory question says, what happens to the coordinates of a point when it's reflected across the x-axis? And to walk through this, we're going to take and use a web sketch pad just to see what's going to happen. In this sketch, points A and B have a special relationship. So we're going to drag point A to locations in different quadrants and observe what happens to point B. Record the coordinates of the points as your observations. What are the similarities and differences in the coordinates of the points? And what do you notice about the location of the their location on the coordinate plane? Where can you drag the points so that the coordinates are going to be the same? So let's take a look. We got point A and point B. Let's zoom in just a little bit. Zoom out just a little bit, I should say. And if I drag point A, you notice at point B, look up here, watch the x-axis up here, see what's happening. X-coordinates, the x-coordinates are going to stay the same. But what happens to the y-coordinates? The y-coordinates are exact opposites of each other. If I go up and down, it makes no difference. The x-coordinates are always going to be the same, and the y-coordinates are always going to be opposites of each other. Doesn't matter where we put those points at. That's because point A and B are going to be reflections of each other. Points A and B are mirror images or reflections of one another. What do you think represents a mirror? Explain your reasoning. And what they said is that the x-axis represents a mirror because when I drag when I drag A, B moves the same way on the opposite side of the x-axis. When I drag A, the x-axis B is, drag A to the x-axis, B is on the axis in the same location. And if we went back to that sketch again, what they were saying here, if we were to take and drag it to the axis itself, when we're at the axis itself, then we have the same exact values for both. The x-axis, so the axis itself, this line right here, that is going to be your mirror, or that is going to be your reflecting point. Okay, everything above it reflects this to be the same exact thing below it. Next, we're going to look at points A and C here, and you're going to see this time that the reflection point is going to be the y-axis. If you take and watch, your y values, your x values are going to be opposites of each other, but your y values are going to stay the same. And if I take and put it exactly on the y-axis, then you're going to get the same exact coordinates for both points. Come off of the y-axis, then your x values are going to be opposite and your y values are going to be the same. So in this case, we are reflecting the 2 points across the y-axis to get to the new point. Points A and C are mirror images or reflections of one another. What do you think represents the mirror image? Explain your reasoning. And the answer that they gave us for that was that the y-axis represents the mirror. Just like I said, when I drag A, C moves the same way in the opposite side of the x-axis. When I drag A onto the y-axis, C is on the axis at the same exact location. The number line shows you that -4 and 4 are opposites. They are the same distance from 0, but on opposite sides. The coordinate plane points -4, 0 and 4, 0 are the same distance from the origin in opposite directions. These points are known as reflections across the y-axis. A reflection, hey, that's a definition right there, better highlight that. A reflection is a mirror image produced by flipping a figure across a line. In the coordinate plane, when you reflect a point across a line, you name the reflected point using a prime notation. This is kind of important right here, so we're going to go ahead and highlight all that because that's some really important mathematical language. In the figure, the reflection of point A, -4, 0 across the y-axis became A prime. And you got to look close to see it, but if you look right there above the A, you see that little tick mark? That little tick mark tells you that it is a prime. So A is going to be your original number, and A prime is going to be your mirrored or your reflected location. That's going to be your new value. For our talk about it, it says you can also reflect a point across the x-axis. Point P is graphed at 3, 2, which is right here. How can you find the coordinates of P prime after reflecting across the x-axis? Well, it is 2, the y value is 2, so it's 2 units up above the x-axis. We would just have to go 2 units below the x-axis in the same location for y for your x, and it would end up being at 3, -2, and that's where point P prime would be. Right, the ordered pair that is a reflection of A, which is located -3 1/2, 2 across the x-axis. So we got the original point, point A is located here. This is the x-axis, and we are flipping across it or reflecting across it. And what quadrant is point A located? It is located in quadrant 2. And in what quadrant will the reflection of point A be located? Well, it's going across the x-axis, so it's going to be down here in quadrant 3. Now we want to find the points of the coordinates that are the same distance from the x-axis as A and graph that point. So we're going to, and then when the point is reflected across the x-axis, the x coordinate is going to stay the same, and the y coordinates, they're going to be the opposites. So what do we know? We know that the x coordinate is going to be the same. It just told us that. So that's going to stay as a -3 1/2, except that, and the y coordinate is going to be opposite, so that means my y coordinate is going to end up being a -2 because it was a +2. Check that, that part checks. Now we're going to come down here, and let's take, and we have the original value is right there. We need to reflect the new value for A prime, and that will end up giving us, get us a dot. It was 1, 2, 3, 4. Let's see, try that again. 1, 2, 3, 4 units above the line. So I'm going to go 1, 2, 3, 4 units below the line. And you can see that that is located at point -3 1/2, -2, just like we said it would be right there. Check the answer checks. Easy math. Now it's going to be your turn. Identify the reflections of the points across the x-axis again. Write the ordered pair of the reflection of P, which are these numbers, across the x-axis. You should be able to do this without even having a coordinate plane to go with it. Stop the video and do it, please. Well, what do we know? We know the x-axis for p prime is going to, the x-coordinate for p prime is going to stay same, and we know the y-coordinate for p prime is going to be the opposite. So my new ordered pair is going to be negative 1 3/4, negative 2 3/4. Check the answer. The answer checks. Easy. Kendall is building a square fence. She places fence posts at locations indicated on the grid. What is the location of the post that reflects S, which is negative 2, 2, across the y-axis? Well, S is right here. We want to go across the y-axis, which is this one. So that means that this post right here is going to be the one that is going to be reflected across the y-axis. That point's value is going to be where X is 2 and Y is 2. So it's going to be an ordered pair of 2 and 2. Check your answer. The answer works. Notice in this case we went across the y value, so where we had a negative 2 for x, we now have a positive 2 for x, and the y value of positive 2 stayed the same in our answer. Now it's going to be your turn to solve the problem. Letitia is building a outdoor dog kennel in the shape of a square. She placed a corner of the enclosure at negative 4, negative 5. What is the location of the corner that reflects it across the y-axis? You go ahead and pause the video, answer that question. I think I might have read the numbers wrong. It was negative 4.5. Negative 4.5 was what we were starting with. Of course, we know when we reflect across the y-axis, the only thing that changes is the sign in front of the x. So we were at negative 4.5. Our prime value is going to be at positive 4.5 for the x. The problem checks. Easy math. Nothing to do on this stuff. Next, we want to take and identify the axis of reflection. So A prime is located at negative 2 3/4, negative 4. And as a result from reflecting A, which was positive 2 3/4, negative 4 in the coordinate plane. Identify the axis which the point was flipped across. Well, what value changed? The x value changed. If the x value changed, that means the y-axis is what you're going to take and flip across. Complete the table to compare coordinates of the original point and the point after. So the x value of our original point was going to be at 2 3/4. So we're going to type in 2 fraction bar 3/4. And don't be confused. A is your original point. A prime was going to be your new point. So your x value of your new point is going to be a negative, let me highlight there, negative 2 and 3/4. Meanwhile, your y values don't change at all on these. In both of them, your y value is simply going to be a negative 4, and your y value here is also going to be a negative 4. Check it, and everything checks good. Now we're going to take and scroll down. It says the what coordinates are opposites. Well, that was the x coordinate were opposites, and the what coordinates are the same. The y coordinates are the same. So point A was reflected across which axis? Well, if you're changing the x coordinates, that means you're flipping across the y-axis. Check our answer. Everything checks. Now it's going to be your turn to do one on your own. The point T prime is at negative 4, negative 6 is a result of reflecting T, which was at negative 5, positive 6 in the coordinate plane. Identify the axis which the point was reflected across. Pause the video, answer the question. Did you get it right? What changed? The only thing that changed was your y value. You went from a positive to a negative. That means that you reflected it across the x-axis. If the y value changes, that means you reflected across the x-axis. Pretty easy math here. And finally, we are at our apply problem, where we're going to look at a real-world problem involving reflections. watch the animation to find out what's going on. So here we go.
Samantha drew a map of the park in her neighborhood. She graphed the point P at -3.5, -3.5 for the playground. The fountain is located at P prime, a reflection of P across the y-axis. The picnic tables are located at the point P double prime, a reflection of P prime across the x-axis. Identify the ordered pair that describes the location of the picnic tables. Then plot the point on the coordinate plane.
Did you catch what they threw in there to you? They threw in a double prime. So if you can look at the picture down here, you saw that they started at one point and reflected across the axis, so that you had point P and point P prime, and then they reflected that across another axis, so we went from point P prime to P double prime. That means there's going to be 2 tick marks for the double prime. So let's break this problem down here a little bit. Samantha drew the park in the neighborhood, and she graphed point P at -3.5, -3.5. Superman runs before he flies, so we're going to go -3.5, -3.5, and that right there is going to be point P. Next, the fountain is located at P prime, which is the reflection across, the y-axis. This is the y-axis. P is 3.5 spaces to the left, so P prime is going to become 3.5 spaces to the right. We're going to call that P prime. Now, we're going to say the picnic tables located at P double prime are going to be a reflection of P prime across the x-axis. So P prime was 3.5 units below the x-axis. That means P double prime is going to be located at 3.5 units above the x-axis, and that will take place where x is going to be a 3.5 and y is also going to be a positive 3.5. With that, we can go back over to our problems. If I can find that particular screen here, right here and then right there, and we're going to take and say that both of them are going to be a positive 3.5. Check our answers, and the answer checks. I think we've covered plenty of material here for you to be ready to totally destroy your homework very quickly. Get started on it. Make sure you get it uploaded to Canvas so that I can give you credit for doing it.